Alright, function rules, tables, and graphs. Now, a function table is just a table organizing the input, the rule, and the output of a function. Remember, input's x, output's y. Now, an independent variable is the input values. Those are the x values. The dependent variable are the output values, the y values. So there's three different types of ways you can express it, or basically view or illustrate a function. The first way is the most common way, by using a rule, like y equals 1/2 x plus 3. The second way is by using a table to show your input values, which are x, and your output values. And the third way is a graph, by showing the trend, or basically the line of the function rule. So when we are looking at this, we are going to first complete function tables. Now this is just modeling each function with a table. Now what you're going to have is you're going to have your x values, your rule, and then your output values. So here in this table I have my inputs of -2, -1, 0, 1, and 2. So my rule is f of x equals -3 times x. So in the middle I'm going to do -3 times -2, which is my input. And then that is going to give my output, which is 6. Then I do -3 times -1, since I'm inputting -1, and that gives me out 3. When I input 0, get -3 times 0, and that's 0. And then when I put in 1, I get -3 times 1, and that's -3. And when I plug in 2, I get -3 times 2, which is -6. Now, same thing with this second table with f of x equals 1/4 times x. I'm going to do my input values, my rule, and then my output values. So when I input -4, 1/4 times -4 is 1. When I input -1, I'm going to get 1/4 times -1 is -1/4. Put in 0, 1/4 times 0 is 0. Put in 1, 1/4 times 1 is 1/4. And put in 4, 1/4 times 4 is 1. Now you can sometimes be given your input values, or sometimes you have to come up with input values. Now if you're coming up with input values, the most common input values are the ones used in numbers 1 and 3. That is -2, -1, 0, 1, and 2. Typically, if you're not given your domain or your input values, then those are the ones that you're going to use to get the best picture of the graph. Now, on number 3, we have y equals 8 minus x. Our input values are -2, -1, 0, 1, and 2. So I plug them into my rule. When I plug in -2, I get out 10. When I plug in -1, I get out 9. When I plug in 0, I get 8. 1, I get out 7. And 2, I give out 6. All of these are complete function tables. Now we'll take a function table and use it to actually graph the function. So this first one I want to graph is y equals the absolute value of x plus 1. What you're going to do is complete a function table in order to get the best picture of the graph. So in this one, I'm going to choose -3, -1, 0, 1, and 3 to give me a good picture of my graph. You want to do some x values that are negative and positive so you get both sides of your graph. So I put in -3. Absolute value of -3 is 3 plus 1 gives me 4. Put in -1. Absolute value of -1 is 1. 1 plus 1 is 2. Put in 0. Absolute value of 0 is 0. So 0 plus 1 is 1. Put in 1. So the absolute value of 1 is 1 plus 1 is 2. Absolute value of 3 is 3 plus 1 is 4. So I'm going to come over here and graph it. But notice, to get the coordinate points on your graph, you're going to take your input values and your output values to come up with your coordinate pairs. So this -3, 4, that's going to give me 1 point. -1, 2 is going to give me another. 0, 1 is going to give me another. And 1, 2 is 1. And 3, 4 is a point. So I'm going to come over here and graph them. First one is -3. Go over -3. Up 4. 1, 2, 3, 4. And put a dot. The next one's -1, 2. So go over to -1. Go up 2. 1, 2. Put your dot. The next is 0, 1. So go to 0, which is right in the middle, go up 1 for a point, and the next one's 1, 2, so go over to positive 1, up 2, 1, 2, put your point, and the last one is 3, 4. Go over 3, 1, 2, 3, and up 4, 1, 2, 3, 4, and put a dot. Now, I connect my lines, and notice with the absolute value function, I get a V. It will always be a V, just a key hint there, always going to be a V when you have an absolute value. Alright, the second one we're going to graph is f of x equals x squared plus 1. Now, if you don't have your input values, remember, do -2, -1, 0, 1, and 2. Set up your function table. When I plug in -2 squared plus 1 is 5. Plug in -1 squared is 1. 1 plus 1 is 2. Plug in 0 squared is 0 plus 1 is 1. 1 squared plus 1 is 2. And then 2 squared plus 1 is 5. So here I have my inputs and my outputs to make up my coordinate points. So -2, 5 is 1. -1, 2 is another point. 0, 1 is a point. 1, 2 is a point. And 2, 5 is a point. Now I'm going to come over here. I'm going to graph them. Okay, the first one, -2, 5. Go over to -2 and up 5. 1, 2, 3, 4, 5 right there. Then -1, 2. And over -1, up 2, there's your point. You got 0, 1, 0's here, up 1, there's your point. And you've got 1, 2, go over to 1, up 2. And you got 2, 5, go over 2, 1, 2, up 5, 1, 2, 3, 4, 5. Notice points that you're putting on here mirror each other on each side with a square when you have that. And notice I get a U shape. Now, I will tell you when you are graphing ones that have a square in it, the U shapes are kind of tricky to draw. So the best way is to you do it without a ruler because it's not a V. So do it without a ruler and draw it to your best ability. You're not going to get counted off if you can't draw a very good U because I can't. Now, in your other graphs, you need to make sure you use a ruler. It's very important, especially when we get down the line to solving systems of equations. That line is going to be very important to do straight. Alright, now let's look at an application problem. So, I have one who charges $3.50 per hour for babysitting, and we need to write a rule to describe the amount of money, and we're going to set that in, earned as a function of the number of hours, which is N, spent babysitting. So, to find how much money he earned, which is M, total amount, you're going to do 350 times the number of hours. So, you got M equals 3.5H. Now, I'm going to set up my function table. Now, remember, we cannot babysit for negative hours, so I'm going to start at 0 because there's no such thing as babysitting for a -1 hour. So I start at 0, I plug in 0, 0 times 350 is 0, then I do 1 hour, 1 times 350 is 350, 2 hours, 350 times 2 is 7, 3 hours, 350 times 3 is 1050, and 4 hours, 350 times 4 is $14. Alright, so here is my graph that I've drawn over here. I put a lovely title, Money Earned Babysitting. Okay. On your y-axis, you're going to have money earned, which is dollars. X is your time and your hours. Time is generally always X, just FYI. Okay, remember your H are your input, M's are your output. So at 0 hours, I make $0. That's why it goes through right here. Okay, at 1 hour, I make $3.50, so I do 1, a little above 3. 2 hours, I make $7, so do 2 to 7. Okay, 3 hours I make $10.50, so I got 3 hours up to about $10.50, which is right there. And 4 hours I make $14. 4 to 14. Now I've connected my dots. Oh, I just erased my line to show you that it will continue. So down here, down along, all I have to do to find out how much I make is go down here, pick my hours, and go up till I meet the line and look over. See how much money I've earned babysitting.